Hello dear student, welcome back to the Pharma Learning channel. Today I came with another unit of another unit person video that is known as the filtration, and let's try to understand what are the theories or what are the basics theoretical fundamentals which is associated with the filtration. Before I go into the detail, if you require for the tutoring or the coaching of need for any of the subject or any of the topic related to the pharmaceutics and the pharmaceutical technology at the diploma level, B Pharm level or at the master's level, please feel free to contact on the email that is the pharmaelearning@gmail.com, or you can contact by this WhatsApp number too. Now let's go into the details, try to understand what is the theory. So before we go into the details, let's try to understand what is going to exactly happen into the filtration. So let's say what is going to be happen. Let's say initially we start the filtration, then what is going to be happening into this one. Okay, as for example, this is the filter medium will be there, and we are adding the slurry over here on the top of this one. So in this case, what is going to happen if the particles are bigger, then the bigger particles are going to be retained on the filter medium, while the smaller particles, means the particles which are having the smaller than the pore size of the filter medium, they are going to pass through the filter medium, and they are going to be coming into the filtrate. But afterwards, as the filtration progresses, what will happen? These larger particles are forming like a pre-coat layer. Okay, pre-coat layer means they're forming a layer and they are tightly hold together, and because of that, on the top of the filter medium, there is a large particle layer will be there, and that large particle layer will try to reduce the effective opening of the filter medium, and due to which you are finding that when the slurry is going to be fed or slurry is going to filter out, the small particles are going to be retained. You can see over here now the various or the very less small particles are going to pass, although the particle size of this is going to be less than the filter medium, but because of the large particle which are going to be form of pre-coat layer on the filter medium, they are going to retain over there. As the filtration processes, what will going to be happen on this one? Again, the solids are going to deposit a large particle, small, and then both together, and so the filter cake formation is going to be taking place. And as the filter cake formation is going to be taking place, in this case, what we are finding, the here, if we are going from number 1 to 2 to number 3, here you as you can see that the thickness of the filter cake is going to be increased, and therefore the amount of the filtrate, that is the clear liquid which is coming out from after passing the filter medium, is going to be also decreased. So let's try to understand how the liquid is flowing through a filter medium. So if we want to find out how the liquid is flow of the liquid which is going to filter medium, then the simple thing is that the rate of the flow of the liquid is the driving force divided by the resistance. Okay, and that's why resistance increases, because resistance is inversely proportional to rate. As the time progresses for the filtration, the resistance increases, and therefore the filtration rate decreases. So generally the rate of filtration expressed in the terms of volumes, that is in the liters of filtrate which is collected for the unit time, and we can express in the terms of we can take a instantaneous, and we can take a like a derivation, and we can express like a dv divided by dt. The driving force is a difference in the pressure from the upstream to the downstream. What is the meaning of upstream? Upstream means from the top, from where we are going to fill the slurry, and the downstream is the area or from which we are going to collect the filtrate. Another thing is the resistance is not constant. As I explained in my previous slide, as the filtration progresses, the resistance is going to be increased because of increased deposition of solid on the filter medium. That's the filter cake thickness is going to be increased, and therefore, as the filtration processes, solid particles accumulate on the filter medium, and that's why forming a bed of solids, and which we are known as a filter cake. So basically the filtration is explained by one of the scientists that's known as Darcy, and he gave the law that's called the Darcy's law. So the filtration rate dV upon dt is equal to P K into A into P divided by eta into L. Now let's try to understand. You know the V is the volume of filter, T is the time of filtration. The K is a constant for the filter medium and the filter K. So this value is going to depend constant, means if you are going to change the filter medium and the solids which are going to be accumulated, so the value of K is going to be differ. The A is the area of the filter medium. As simply, if we are going to provide the larger filter medium, okay, that's a larger filtering area, then the rate of filtration increases. If we are going to provide the P is the pressure drop, that is above and the below the filter, it means that it's difference between the upstream and the downstream. So if there is a more pressure difference will be there. In this case, if the more pressure difference, then the rate of filtration will be higher. So it is advisable in this particular case, when we are going to fit the slurry, at that time to increase the rate of filtration, just have the, because and otherwise the slurry is going to filter out in the case of the gravitational force. But we apply the some pressure or the force, or we stir the slurry from the feed station, it will increase, or apply the pressure, then it will increase the rate of filtration. And simultaneously, if we going to at the time of at the place of filtrate receiver, if we are going to apply the vacuum, okay, so that is a suction force, so that will take out the liquid very fast, so that is going to be also increase the pressure drop. So we can increase the rate of filtration either by increase the pressure on the at the feed point, or by increasing the or applying the vacuum or the suction at the filtrate receiver, or both the things together. The eta is the viscosity of the filtrate, that is inversely proportional to the rate of filtration. As we increase that, if our liquid is water and the liquid is oil. Okay, so in either of these cases, if you have the slurry prepared in the oil, it is going to be have the more viscous, so it will need the more provide reason, and that's why the filtration rate is going to decrease. And as I just explained, that's L related to the thickness of the filter bed or the filter cake. So what we can say that the factors which are affecting the rate of filtrations are basically the pressure drop from the feed to the far side or from the upstream to the downstream, that already I explained. The filtering surface area, yes, try to increase the filtering surface area by taking a large filter medium, or you can take the small filter medium and try to arrange into the series. Uh, Also the filtrate viscosity, the resistance offered by the filter cake, and the resistance which is offered by the filter media. The reason of about the filter medium, it means like sometimes we are going to use the filter medium which is thin in nature, like a paper, filter paper. But sometimes we are going to use the like a filter medium which is thick in the nature. Like we are finding the sinter glass filter will be there, which is thick in the nature, and which is basically made up of like a glass particle and having the much more thickness. So it will also affect the rate of filtration. So if you like my video, then please give it like, and please subscribe to my pharma learning channel for more upcoming videos related to the pharmacy. Thank you.